Alright, so today's lesson we're going to be going over lesson 7 in your notes packet, which is on percent composition. So, for percent composition, basically the chemical formula of a compound shows the exact ratio of the different elements that are present. The numbers of each element are recorded using a subscript to the right of the element's symbol, which we have studied before, such as if you have H2O, you know that there's 2 hydrogen, 1 oxygen. When only one atom is present, the subscript 1 is assumed or understood, just like H2O. There only is 1 oxygen, but we just kind of know that. To determine the percent composition in a chemical formula, we do this for each individual element. So what you would do first is you would express the mass of each element as a percent of the mass of the compound. So it's often necessary to find the percentage of each element in the compound to determine its formula. So for example, if you had a substance that you're trying to determine the identity of, you would start with finding the percentage of each element in the compound. Once you know the percentage, you can determine the formula. So down here we have this equation. So to determine the percent of each element, use the following. So the percent of the element in the compound is the molar mass of the element divided by the molar mass of the compound times 100. So this example we have here, we're going to determine the percent composition of KNO3, which is potassium nitrate. So the first thing that we need to do is we need to figure out the molar mass of the whole thing. So we have on the board back here, if we want to figure out the molar mass of potassium nitrate, so we have potassium nitrate, KNO3. So we have 1 potassium, 1 nitrogen, 3 oxygens. So we add all these up using the periodic table. So potassium has a mass of 39.10, nitrogen has a mass of 14.01, and we have 3 oxygens, each with a mass of 16.00. Alright, so if we add these all up, the molar mass that we're going to get is 101. So 101.11 grams per mole. So we want to decide or determine the percent composition of each element. We're going to look at each element individually. So let's look at potassium first. So potassium, which is K, we need to decide the molar mass of that element. So potassium, there's only 1 of them, and the molar mass of potassium is 39. Okay. The unit for this would be grams per mole. We divide it by the total molar mass, which is 101.11 grams per mole. And we multiply by 100 because it's a percentage. So we multiply by 100 at the end. We're going to get 38.7%. Okay? Now, we need to look at the next example here, which we have nitrogen. So nitrogen, there's just 1 of them. And again, the molar mass is 14.01 grams per mole. We divide it by the total mass of the whole thing, which is 101.11 grams per mole. Multiply by 100. And we're going to get 13.9. Alright, and then finally oxygen. We have 3 of them, so this one is just a little different. So we need to take 3 times each one has a mass of 16. Divide it by the whole thing, which is 101.11 grams per mole. Multiply by 100. And we're going to get 47.5. Now, there's a quick way of checking these when you do a problem like this. You can check and make sure that all these add up to 100, just to know if you're doing things right, okay? Alright, so that's essentially how we go about these problems. So that's how you would determine the percent composition of potassium nitrate. This next example here is a little different. We have 25 grams of potassium nitrate. We want to know how many grams of each element we have. So, since we have these percentages, what we can do is work with them off of our total mass. So the total mass we have is 25 grams. So you need to convert these to a decimal. So that'd be 0.387. This one would be 0.139. And this one is 0.475. You would take that converted percentage and multiply by the total mass that we have. We have 25 grams, as it says right here. 25 grams potassium nitrate, so we multiply by 25 grams. Alright, so once we go ahead and do that, we're going to just calculate those out. So our final answer here for potassium would be 0.387 times 25, which is 9.68. So you have 9.68 grams. Nitrogen, we're going to multiply these out. For nitrogen, we're going to get 3.48. And oxygen is going to be 11.88 grams. Alright, so there's an example of how we would first figure out the percent composition of all of the elements that are present in that compound, and then how we would determine what mass of the total mass is responsible for each element. Okay? Alright, so next we're going to talk about something a little different. There's another example there. You can go ahead and give that one a try. It's very similar to the ones we just did. So, this is a little different. We're going to be dealing with hydrates. So, hydrates essentially have water molecules trapped inside the crystal lattice. That's the composition of the hydrate. Basically, what you need to know is that there's water involved. So, we have these water molecules trapped, and this makes these compounds have a unique formula because they have these water molecules attached. They also look different. So here's an example of a formula for a hydrate. You see copper sulfate here, so copper 2 sulfate, and then we have this kind of part here. This asterisk basically means that there's water involved. It's not a multiplication sign. It's kind of represented that there is attached water to it. This one has 6 kind of molecules of water here. And because of that, it's called copper 2 hexahydrate. Hexa meaning 6. Alright. So, when you determine the molar mass of these hydrates, you add the molar mass of the water to the molar mass of the anhydrous salt. The anhydrous salt means without water, and we'll be doing elaborate work with these hydrates. So, the first thing we need to do here is we need to find the percent water in the above mentioned hydrate. So, you have this example here in your notes. This is on page 13. So, in order to do this, the first thing we need to do is determine the molar mass of the entire hydrate. So when we determine the molar mass of these hydrates, you need to take into account the fact that we have this water. So we have copper sulfate is the first part. Alright, so copper, the molar mass of copper is 63.55. We're going to add 1 sulfur, which is here. That's 32.06. And we're going to add 4 oxygens. Now, we have 6 water molecules here. The molar mass of water is 18, so I'm going to add 6 times 18 for 6 water molecules. So if we add that all up, we're going to get 267.61 grams per mole. Similar mass of the whole entire thing, that hydrate. Now, we need to find the percent water in the above mentioned hydrate. In order to do that, we want to know the percent of water. We need to talk about, first of all, how we figure out what is the molar mass of the water that's involved. So we have 6 water molecules. That means we have 6 times 18, or each 18 grams per mole. We're going to divide by our total molar mass here, which is 267.61 grams per mole. And again, it's a percent, so we multiply by 100. So when we take 6 times 18 and divide it by the total mass there, we're going to get 40.4%. Alright, so our answer for finding the percent water in the above mentioned hydrate is 40.4%. Now, here's another problem that's very similar. What we need to do here is we need to calculate the percent water in this other hydrate here. So you have NiCl2 and 6 waters, so it would be a hexahydrate again. So in order to do that, you're going to do the same sort of thing. First step is calculate the molar mass for this new hydrate. After that, figure out the percent water by taking how many waters, so we have 6 again, so this would stay the same, with the new molar mass on the bottom, and divide those out and multiply by 100. Alright, and that's pretty much it. We'll be doing some problems similar to the next couple that you see in your notes packet together in lab. So for now, I would say that that's what you need to be comfortable with, and we'll be doing some practice problems together in class on these things.